we will discuss how to calculate the mean absolute deviation. As I mentioned in the previous video in box and whisker plots, mean absolute deviation is another way to calculate the variability or spread of a set of data. The mean absolute deviation is used in a lot of different scenarios. Here are some examples of times when mean absolute deviation is used in everyday life. The purpose of calculating the mean absolute deviation is to find how far something or a set of data falls from the average. So the mean absolute deviation is the average distance between each data value and the mean. It will tell you whether or not a set of data is more or less spread depending on the mean absolute deviation. A set of data with a smaller mean absolute deviation has values that are less spread from the mean than a set of data with a larger MAD. In order to calculate the mean absolute deviation, you need to first find the mean of the set of data. Once you find the mean, you then need to find the difference between each data value and the mean. Then finally, you'll find the average or the mean of the differences. So let's take a look at an example. In this example, the number of inches of rainfall and snowfall per year are shown by city. Find the mean absolute deviation for each data set. Compare their variations. What does the MAD tell you about the data? The first thing we'd want to do is find the mean for each set of data, the rainfall and the snowfall. The mean of the rainfall data is 39. The mean of the snowfall data is 28. Once we calculate these means, the next thing you want to do is find how far does each individual piece of data fall from the mean. So for example, our first city has 50 inches of rain per year. That is 11 inches from our mean of 39. The second city is 48 inches of rain per year. That is 9 inches from our mean. 45 is 6 inches from our mean of 39. 32 is 7 inches from our mean. And 20 is 19 away from our mean. Regardless of whether it is greater than the mean or less than the mean, we are going to write all of our answers as positive values because we are just looking at how far is it from the mean, not whether it's greater or less than the mean. We'll do the same thing for the snowfall data. The first city, 15, is 13 inches away from our mean of 28. The second city, 30 inches, is 2 inches away from the mean. 10 is 18 away from the mean. 35 is 7 away from the mean. And finally, 50 is 22 inches from the mean. Once you find how far each city is from the mean of all 5 cities, the last thing you want to do is find the mean, again, of the differences. So you're going to add these numbers up and divide by the number of cities of data we have. That's 52 divided by 5. This gives us a mean absolute deviation of 10.4 inches for the rainfall data. And these add up to 62. And 62 divided by 5 is 12.4. So that gives us a mean absolute deviation of 12.4 inches. So the question is, compare their variations. What does the MAD tell you about the data? So we can see from the mean absolute deviation that the snowfall data is more spread out from the mean than the rainfall data because the mean absolute deviation is greater. So this means that on average, each city is about 12.4 inches from the mean, versus the rainfall data, each city is only about 10.4 inches from the mean. So those are closer to the mean than the snowfall data. This next question can actually be answered most likely without actually calculating the mean absolute deviation and just taking a look at the spread of the data. So see if you can answer this question without actually calculating the mean absolute deviation for each team. If you would like to calculate the mean absolute deviation for practice, you may do that as well.